Alhamdulillahirabbil alamin wa bihi nasta'in ala umuri dunya waddin. Assalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa ashabihi ajma'in amma ba'du. Good afternoon, ladies and gentlemen. Welcome to the 2022 General Lecture of Textile Engineering Department, Faculty of Industrial Technology, Universitas Islam Indonesia. Today, on Wednesday, June 29th, 2022, we are proudly presenting to you General Lecture under the topic of Sustainable Textiles, Introduction to SaxCell and its Potential Applications. The lecture will be presented by our honorable speaker, Dr. Jens Ulerik. He is an associate professor in sustainable textiles from Saxion University of Applied Sciences, the Netherlands. My name is Budiman, and I will conduct this lecture event so you can enjoy your nice afternoon with us. We would like to say welcome to all of you. Insinyur Dr. Andes Faisal RM, MT PhD as the head of Textile Engineering Department. Our honorable speaker, Dr. Jens Ulerik. Hello, Dr. Ulerik.
Hello.
Yeah,
good afternoon to everybody.
Good afternoon. Welcome to our university event. How about the weather in your place now?
Well, it's actually quite sunny. There's day starts with the nice weather.
Okay.
It's 9 o'clock at my place, so good morning as well.
Yeah, it's 2 p.m. here, and also it's a sunny day here. So we hope it will be a good day to learn together with you. And then the lecturers and students from Textile Engineering Department who are both attending in the class offline and also joining us by Zoom online. And finally, all guests and attendees who are joining this lecture event from all over Indonesia or maybe around the world. Allow me to mention the agenda of the event today. First will be the opening, second, opening remarks, third, lecture from Dr. Ulerik, fourth, Q&A session, and the fifth, closing. Before the opening, we kindly remind you to mute your microphone during the lecture, but you might turn your camera on along the event. If you have questions, please write it down in the chat box and we will deliver your questions in the Q&A session. Or if you are in the class, please raise your hand and unmute the microphone in the class. Burina will help you to ask your question. We have sent you the virtual background in the chat box. Please kindly download it and put it on as your virtual background. Ladies and gentlemen, without waiting any longer, let's move to the first agenda, which is opening. Let's open this event by reciting Basmalah. Bismillahirrahmanirrahim. Move to the next agenda, which is opening remarks. This greeting speech will be delivered by the head of Textile Engineering Department to Insinyur Dr. Andes Faisal RM, MT PhD. The time and screen are yours. Sorry, Mr. Faisal, your microphone still mute.
Ya, terima kasih Mas Budiman yang telah sudi menyilakan saya untuk memberi kata pengantar sebagai Ketua Program Studi Rekayasa Tekstil Universitas Islam Indonesia. Selamat datang, ya, Dr. Jens Ulerik, ya, dari Saxion University of Applied Sciences, Netherlands, yang telah bersedia untuk menjadi narasumber dalam kuliah umum siang hari ini. Semoga bermanfaat bagi kita membagi khalayak. Jadi kami nyambut baik, ya, kesediaan dari Dr. Jens Ulerik, ya, sebagai narasumber dari Saxion University of Applied Sciences, Netherlands, yang mana meskipun jauh dari mata tapi dekat di hati gitu. Jadi harapan kami ini sudah yang kedua kalinya untuk narasumber dari luar negeri, ya, atau mancanegara yang sudi bicara sebagai narasumber dalam kuliah umum. dari ya khususnya kami dari kalangan dosen dan juga mahasiswa dan juga umum. Jadi acara ini terbuka secara umum nih, siapa saja yang tertarik dengan topik yang diangkat dalam webinar via Zoom ini. Jadi kami juga ingin dengan adanya bicara dari luar negeri ini akan memperluas wawasan bagi kami dosen dan juga mahasiswa dan bagi siapa yang membutuhkan agar kita selalu mengikuti perkembangan pengetahuan dan sains ya untuk ya menggapai kemajuan terus khususnya di dunia tekstil ya. Kami juga mungkin mohon maaf apabila dalam pelayanan mengadakan webinar kuliah umum ini ada kekurangan di sana sini yang tidak kami sengaja. Manusia tidak lepas dari silap dan salah penuh dosa. Jadi kami mohon maaf, ya mohon ampun kepada Allah. Semoga kuliah umum pada siang hari ini berjalan dengan lancar, mencapai apa yang kita harapkan ya. Jadi kami dari Prodi, ya ini mungkin masuk Prodi yang pertama dan satu-satunya di Indonesia yang menyediakan pendidikan tekstil strata 1 atau bergelar ya. Saya kira mungkin itu dari kami. Terima kasih ya, dari narasumber ya Dr. Olerik ya yang sudi mengisi kuliah umum siang hari ini. Terlebih terkurang mohon maaf. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. So to Dr. Yulerich, Mr. Faisal just say welcome to our event. Thank you for being with us. Although we are far by distance, we separated by continent and ocean, but between Universitas Islam Indonesia and Saxion, we are near by heart, like that. And then before continuing to our main lecture, we would like to take a documentation of our wonderful event today. Please turn your camera on. If you join by devices such as laptop or PC, personal computer, please download our virtual background, which already sent in the chat box, and put it on for your virtual background. So we will give you like 2 minutes to prepare your camera on, because we will take documentation before the lecture. Kepada para peserta, mohon dapat menghidupkan kamera dan mendownload virtual background yang sudah kami share di kolom chat. Kami berikan waktu sekitar 2 menit untuk menyalakan kamera serta memasang virtual background yang sudah kami share di kolom chat. Okay, I will take the screenshot from here. Please give your best smile. 1, 2, 3. Once more. 1, 2, 3. Okay. Thank you, ladies and gentlemen. Today's general lecture is held by Textile Engineering Department, Faculty of Industrial Technology, Universitas Islam Indonesia. Now, we are going to show you a bit of video of our department, which is the pioneer and the only one of bachelor degree program for academic in textile engineering in Indonesia. Happy watching.
Dapatkah kamu bayangkan, kampus pionir pendidikan tinggi di Indonesia ini adalah kampusmu di masa depan. Kampus Islami yang terbuka bagi setiap warga negara, tempatmu belajar akan arti indahnya kebersamaan di tengah-tengah keragaman, tanpa harus melupakan arti penting ketaatan pada nilai-nilai keislaman. Dapatkah kamu bayangkan mengecap pengalaman global di kampus mondial dengan beragam rekognisi internasional di program studi dengan akreditasi dan sertifikasi dari berbagai negara seperti Jepang, Korea, Inggris, hingga Amerika. Tempatmu mengeksplorasi ilmu pengetahuan lewat 8 pilihan fakultas dengan 48 program studi yang ditawarkan. Menjadi tempatmu menjemput impian sembari bebas menikmati petualangan kolaborasi dengan ilmuwan dunia. Seraya memperluas wawasan lewat berbagai program kemitraan yang tersebar dalam skala nasional maupun global. Dapatkah kamu bayangkan, kampus swasta paling lestari di Indonesia ini adalah tempatmu menempuh pendidikan tinggi? Kampus unggulan dengan berbagai inovasi berkelanjutan di berbagai bidang. Tempatmu belajar dengan bebas, di tengah rindangnya taman atau dalam nyamannya ruangan. Di luar maupun dalam jaringan, semuanya tak terbatas ruang kelas, tak terhalang jarak dan ruang. Semua disediakan untuk mendukungmu menjadi generasi muda yang aktif dan inovatif dengan keragaman pemikiran yang berbuah menjadi beragam apresiasi. Dapatkah kamu bayangkan jika kampusmu kelak adalah tempat yang mendukungmu sebagai intelektual, tidak hanya cerdas secara akal, namun juga cerdas spiritual di kampus swasta terbaik dengan akar yang kuat dalam tradisi kebebasan akademik, menjadikanmu berani mengekspresikan diri di tengah-tengah zaman yang penuh dengan kompetisi untuk berkontribusi akan solusi dari masalah yang dihadapi. Para sivitas akademika serta lebih dari 107.000 alumni pun telah membuktikan diri menjadi insan ulil albab yang mampu mengintegrasikan ilmu pengetahuan dan ajaran Islam dalam menebar kebermanfaatan di bermacam rumpun keilmuan. Dapatkah kamu bayangkan apabila kampusmu adalah salah satu kampus yang berlokasi di kota pendidikan ini, kota Yogyakarta dengan segudang cerita dan budaya yang beraneka ragamnya, dan Universitas Islam Indonesia hadir sebagai kampus Indonesiawi, berdiri berdampingan dengan ilmu pengetahuan, budaya, dan seni yang memberikan warna indah dalam harmoni. Kini berhenti membayangkan dan sudah saatnya bersiap untuk mewujudkan. Siapkah kamu? Karena kami siap untuk menunjukkan jalannya.
Yogyakarta, a city of profound stories about culture and history, it is well known with its batik, a unique traditional art carved by the hands of elderist artists, who await the younger generation to take their role and the legacy as a timeless heritage. With a pride of heart and self-trust, we believe this is the right time to step forward and bring this heritage to future glory. That little step starts with making the right choice. Lying in the special city of Yogyakarta, which is renowned for its hospitality and diverse culture and traditions, Universitas Islam Indonesia has been established in 1945 with an integrated campus that stands on the area of 35 hectares on the north side of the city of Yogyakarta, holding the record for the best private university of 2018 by Kemenristek Dikti with a 3 stars rating by Stars. UII provides state-of-the-art facilities that support academic activities. And life necessities for all students and teaching staff. Universitas Islam Indonesia proudly presents the Textile Engineering Study Program as a pioneer program for undergraduate level in the development of textile industry in Indonesia. It concerns on studies in design and control for all processing stages in the textile manufacturing to become a textile product. The program offers the best facilities to support the learning process that is driven by lab work without putting aside the importance of batik as our cultural heritage. The learning methods are mainly conducted through lab works and simulation to improve students' understanding in applying theories derived from classroom learning. To prepare quality human resources in the textile industry, we provide the fashions and clothing field with state-of-the-art equipment and standardized test equipment that meets national standard accreditation requirements. Thus, the study program of textile engineering has a recognized test output and can contribute to academic researches conducted by students and lecturers, both for the internal and external institutions at the national and international research scope. Our professional teaching staff and expert in the field of textile engineering along with the expert are always ready to assist students both in terms of academic and non-academic aspect. In fact, every student is encouraged to take part in various national and international non-academic activities. In a vision to become a study program that develops technology and contributes to the positive changes in the field of textile manufacturing throughout Southeast Asia, as proven by wide-ranging collaborations with countless top-ranked universities worldwide as a way to provide the community with knowledge and technology. Universitas Islam Indonesia always comes up with the best graduates to develop the nations. With a magnificent fighting spirit, we will continue to gain more achievement and innovate to preserve the country's cultural heritage as a pride of the nations. In these young hands lies the hope to showcase the nation heritage to the world. Achieve your success today.
All right, thank you. So that is a glimpse of our textile engineering department. For further information, please visit our website at textiles.uii.ac.id, or you can also visit our Instagram at rekatex.uii. Ladies and gentlemen, we kindly remind you again to mute your microphone during the lecture, but you might turn your camera on along the event. If you have questions, please write it down in the chat box and we will deliver your questions in the Q&A session. And now, let's move to the central of this event, which is the lecture itself. The lecture will be delivered by Dr. Ulrich, but before that, we would like to show you a short of his bio. So Dr. Jens Ulrich is Associate Professor Sustainable Textiles at Saxion and the project leader of several Dutch projects about chemical recycling of polycotton and the optimization of yarns for silk road products. Dr. Ulrich is convinced that the necessary change towards a sustainable industry can only be reached if raw materials are renewable and kept in circular loops with a minimum environmental impact. He sees sustainability and innovation as the driving force for new developments in the European industry. In 2019, Dr. Ulrich organized an international symposium about the transition from post-industrial to post-consumer waste recycling. Dr. Ulrich is a co-founder of SaxCell BV, a chemical recycling company for cotton, as well as founder and director of Impartex BV, a consulting company for textile recycling and the circular economy for textiles. At Saxion, he is a senior lecturer in the textile chemistry, sustainable textiles and scientific writing and at the master's program Innovative Textiles Development. So without any further ado, please welcome Dr. Jens Ulrich. To Dr. Ulrich, the time and screen are yours.
Okay, good afternoon. Welcome everybody. Salam alaikum to everybody. I see that there are a lot of people online, and I also saw quite some students in the classroom. That's great to see. I will share my screen and I hope it works for you. Can you see my screen now?
Yes.
Perfect. That works well. So good afternoon, everybody, again at my place, actually in Germany, where I'm now close to the border to the Netherlands, where the University of Applied Sciences, Saxion in Enschede is located. It's quite a sunny weather, as I said before, and it's 9 o'clock in the morning. So this is actually the first thing that I do today. For you, it has been already quite some time in the day, but I hope you're still able to listen to my lecture, and I'm really looking forward to also have a discussion about this topic at the end of the lecture. So what I would like to present to you today is our research work at the University of Applied Sciences in Enschede, and to give you an idea where we are located, this is the map of Europe, and I don't know if you can see my pointer, but we are quite in the center of Europe, close to Germany, and Enschede is actually the main city of Saxion University of Applied Sciences. We have about 29,000 students, 60 bachelor and master programs, and 40 research groups, and actually we have two study courses that are related to textiles. One is the bachelor course Fashion and Textile Technology, and one is the master course Innovative Textile Development. Our research group, which is closely connected to our education, is the research group Sustainable and Functional Textiles. We are currently about 13 researchers from all different disciplines. Our research group is headed by Dr. Jan Mahi. He's the professor of Sustainable and Functional Textiles, and I'm associate professor helping him to coordinate the research line of sustainable textiles. Since textiles, as you know, is quite a multidisciplinary research field, we have quite a lot of different disciplines in our research group, from chemistry to physics and biomechanical engineering, but also fashion design and textile engineering, of course. We are currently expanding our research group since we see that the needs for research in sustainability related to textiles is really, really high. What we do in our research is actually called applied research, since when you look at this technology readiness level scale, we are, with our research, located in between the academic research, which is done on universities that do fundamental academic research, and the industry. So as you see this scale, we are transforming the knowledge that is generated at fundamental research universities towards the industry. So we are always closely working together with industry and helping industry with the challenges they have. Our research group consists of two research lines. One of that is sustainable textiles, and the other one functional textiles. In the sustainable textile research line, we are actually looking at topics like circular design, tracking and tracing of textiles, but our main research focus is actually in the recycling, where we distinguish between the mechanical recycling technologies and the chemical recycling technologies. And the biggest topic of today is actually into the chemical recycling, where I would like to introduce you to SaxCell, which has been an innovation from our research group and is now, as you heard in my bio, an independent company. Our second research line is functional textiles, where we look at technical and smart textiles, but also medical textiles and digital processing. Coming to the main topic of today, which is actually the circular economy of textiles. When we look into the textile production and industry, you know that there are a lot of challenges regarding sustainability. And in Europe, we are currently facing the change of the linear business models, where we have the production, the use, and then the waste phase of the products, towards circular business cases in the circular economy. And in the Netherlands, we always use for this economy the R strategy, the R ladder, as it's called in Dutch, where you can see 9 strategies to reduce actually the landfilling waste. First, of course, we should refuse the use of our textiles. That means use less if you don't need it. We have seen that fast fashion in European countries at least, but I think all over the world, has led to a tremendous increase in the use of textiles. And that use is not longer bound to the needs of the textiles to cover our body and to feel safe. It has been shifted to fashion and to look nice with the clothing and to have as much of fashionable items as possible. And we think that this system cannot longer stand in as it is, because we think that we see that it has a large impact on the environment. So we should also rethink our textile use and reduce it by this as well. And of course, you have other strategies to keep textile materials in life, as repair, refurbishment, and remanufacturing processes. And I think this is very valid and should be done more and more. Keep textiles in use as long as possible. But at some point in time, textile materials are at a stage where they enter the end of life phase. So you need to do something to bring them back into the cycle. And that's actually R8, the recycling activities. And this is where we have our main research interest, because if we look at the product breakdown, the structure of textiles, you can of course reuse the product, reuse the fabric, but then you get quite quickly into the recycling of fibers and the recycling of polymers or molecules. As you know, all textile materials are built up from polymers, which on their part are built up from smaller monomers. We can use different technologies to recycle the material as good as possible. We are focusing actually on the mechanical and chemical recycling. At the end, if you can't do anything with the material anymore, there's still the chance to go into the biorefinery and make, for instance, biofuels from cellulose or something. Why is that necessary? And I think most people working in textiles know this picture from the Ellen MacArthur Foundation, which shows quite well the problem from the textile industry. At the moment still, and that's the picture from 2018, but I think it will not change a lot in time, more than 70% is landfilled or incinerated in the textile industry. And only like 13% are kept in the loop of recycling, from which only less than 1% is actually in the closed loop recycling, which means that you produce textiles out of old used textile materials. So this textile to textile recycling or closed loop recycling is really not developed yet, and it should be, because we are facing problems in these old business models, sending our textile waste to landfills or incineration. In our research group, we focus on cotton there, because we think that in cotton you can do a lot to keep the material in the loops. And we see that in Europe, for instance, there are more than 9 million tons of textiles which are annually incinerated or landfilled, from which of, I think, 10 to 15% are directly suitable for chemical cotton recycling. And the nice thing about cotton is actually that while using it, it gets more pure. What I want to say with that is that cotton, as you know, is consisting of cellulose, hemicellulose, lignins, and fats. But the hemicellulose and the lignins and also the fats, of course, are reduced to the content during the production phase of our garments and also during the use phase of the cotton. So where cotton, when it's harvested, has around 90% of alpha cellulose content, the cotton waste has a higher cellulose content, which is more like 96 or 98%, which actually makes the chemical recycling of cotton waste very nice to do. The problem is that, as you know, textiles are not only consisting of cotton. Often we have other contaminations as polyester styrene threads, labels, dye stuffs, elastomers, and those kind of issues. So in our recycling strategies, we actually try to clean up the cotton from all of these ingredients to recycle it. And I will show you some of our processes that we developed. In general, we can distinguish in the recycling of textiles between the classical mechanical recycling and the chemical recycling. In the mechanical recycling, you use large mechanical machines with nails that tear textiles apart, and you can get from woven or knitted fabrics quite fluffy and well-opened structures back. The problem there is that you damage the material while doing this. So you're damaging the fibers are getting shorter, and if you only would do mechanical recycling, you can't get the same quality of products back as you had before. That's why we actually think that the chemical recycling is very necessary for the textile industry, because chemical recycled fibers can have a much higher strength, and you produce them as filaments, so you can cut them in any length as you desire. Why did we look into cotton? There are some known chemical recycling processes for textiles. In Italy, in Europe, we have a company which is called Aquafil. They have a product, Econil, which is produced from polyamide 6, which is done by chemical processing it back to the monomer, cuprolactam, and then you can polymerize it back to polyamide 6. That's a well-established technology. That's why on the scale of technology readiness level, which I've shown you before, this technology is at 9, which is close to an industry. Other materials that we have in the textile industry, as polyester and elastomers, there the chemical recycling has not been developed that far. We have in the Netherlands also initiatives to look at polyester, but this is at a lower technology readiness level. So what I've shown before is that in the applied research, we can do a lot on cotton technology, actually. If you look into the properties of recycled fibers, as I've shown you before, the mechanical recycling, the nice thing about that is that it has really a low environmental impact. You need just some mechanical forces to tear apart the textile products. You keep the cotton-like appearance and properties of those fibers. However, you are reducing the fiber length. And of course, with mechanical recycling only, you will keep the color of the material at the end. In the chemical recycling of cotton, you have a lot of variations actually, because what you need to do is to purify the waste textiles into a pulp, which is consistent of only cellulose. And from that pulp, you can produce new textile fibers with known or new processes that are in development. And you know, for example, the processes to make regenerated cellulose fibers, like the lyocell process or the viscose process. Those are processes that you can go into with this purified cotton pulp. And of course, those fibers all have different advantages and disadvantages. With our SaxCell technology, which I introduce in a minute, we are looking into the lyocell technology because we think that this is has the highest potential for a chemical recycling closed loop for textiles. The lyocell fibers, as you know, are very strong mechanically. They are known to be a high-end fiber, which also comes, of course, with a higher costs. But those are very nice fibers to keep them in circular loops. Then, of course, you have the viscose fiber, which is actually a very flexible process. You can produce different types of fibers with it. However, they are often mechanically weaker, but they come with a lower cost, and it's the industrial standard at the moment. Then some other technologies that you can use are carbamate technology or fibers from ionic liquids. However, with carbamate, the fibers are mechanically much weaker. And with ionic liquids, the problem is that those ionic liquids are rarely used still, so they come with a very high costs, and this still needs time to be implemented in industry. We faced some general challenges with the chemical recycling of textiles. As you know, textile waste is not an homogeneous feedstock. It's very changing a lot in time, and it's heterogeneous. Elastomers are a very big problem. They are used more and more in textile products, but for recycling, they are really an issue, as well as intensive and dark colors. The market wants white fibers, and also recycled fibers often needs to be white, which I think we need to overcome this hurdle. So we should ask textile designers to also make use of colored recycled fibers, but still the wish is there to have white fibers. So you need to uncolor. And so that means you need a lot of chemistry to get the waste color textiles white. In the technology, there is still the barrier of upscaling. We have a lot of initiatives on laboratory and pilot scale, but on industrial scale, there are only a few available at the moment. That is also depending on investments. There was quite a lack of investment for those technologies, but now with the new strategies in Europe, you see that there are more investments into those type of technologies. And the low virgin raw material prices for cotton and polyester were also a hurdle for the economics of these technologies. Next to that, at least in Europe, we had quite reluctant buyer attitude, which means that the consumers that should buy recycled materials actually said that they don't want to spend more money on recycled materials than on virgin materials, since they had in their mind that recycled materials are of lower quality. So that needs to be overcome as well. But of course, there are also some possible solutions for the feedstock, which is heterogeneous. We are looking at automatic sorting. We make categories of textiles, which have then a reliable purity of the feedstocks. And one aspect which should not be underestimated is the design for recycling aspect. In my opinion, designers are the key to a circular economy because they determine in their design of a product already if that product can be recycled in a good way at the end of its life or not. If you have many materials in your product, many mixed blends and accessories and gadgets and other things on your textile, you can be sure that it's very difficult to recycle it at the end. In the technology, we do a lot of research and development. There are a lot of feasibility studies, and we are building actually, and I will show you that at the end of my presentation, a lot of collaborations within the value chain of textiles, because that is necessary to have the necessary links between the players in their value chains to make this change possible. In the EU, we have quite some investments in circular and sustainable products, like the Green Deal of the European Union. And we see that we have more and more regulations like extended producer responsibilities, which means actually that the producer of textiles is responsible for the material throughout the life phase. So they have to have take-back systems or those kind of initiatives in place. And we, of course, try to inform our customers and the market with transparency, which means that we show the value chains of our textiles, and we are working on product passports where consumers can see where the raw materials are coming from, or if it is virgin cotton or recycled cotton, where the yarns are made, where the weaves are made, where the textile is knitted or woven, which should be transparent to the consumer, and that we think will increase awareness of the consumer. If we look at an ideal cotton material cycle, of course, we start with cotton as a raw material, which goes into the normal production circle of textiles. But at a certain point, it will be a waste, which then is the raw material for the next phase by collecting and sorting. And then without a good technology in place, there is a missing link between the collecting and sorting and the raw material. And we think that the SaxCell technology can be this link between there. The SaxCell technology is actually more than 10 years old. We started 10 years ago in our research group by the ambition to transform waste into a valuable raw material. And we knew that the textile industry is quite conservative. That's also in the Netherlands. They actually want to stick there to their old processes and the old way of producing. So we knew that we need a technology with low investments in processing machinery. The fiber that we wanted to develop needs to fit in the existing supply chains and have a large scope of applications. And of course, why are we doing this? At the end, this production should be more sustainable than going from virgin products, raw materials. So we looked into the chemical cotton recycling, and this process that I will show you actually consists of 10 steps that are all necessary. And what I've said before, we need collaboration in the supply chain for that. We start with waste collection and sorting. For that, you need a collection and sorting company that is really focusing on getting the good waste streams in. Then we start with unraveling or milling to get those kind of purified feedstocks that are rid of buttons, dippers, and other accessories. And then actually the chemical technology starts with the removal of polyester and other impurities, the discoloration of the remaining textile waste, and there's a necessary step, which I'll explain later in more detail. We need to adjust the polymers in cotton to fit into the recycling process. If we have done that, we can spin in a wet spinning process, as you can see here, with a spinneret, regenerated cellulose fibers. And I've said before, we are looking into the lyocell process here. And then if you have those, you can go into the traditional processing and make yarns, fabrics, and garments out of it. And then, of course, those garments should enter the cycle again. The technology that we develop is actually in the pulping, which means you transform colored waste streams of textiles into purified cellulose for regenerated cellulose fiber spinning. So we did that with different kind of waste streams, and what we got as a product out of this was a staple fiber of 1.8 D-Tex, and we cut it into 38 millimeters, which is the normal cutting length for lyocell type fibers. And we got very good mechanical properties for it, and have shown that those fibers are suitable for the common textile processing. As you can see, typically for lyocell fibers, what you find in literature is that they are around 36 centinewton per tex in tenacity, and here we reached 43 centinewton tex, so we even have a stronger fiber than the commercially available lyocell fiber. We have shown that these fibers are processable in many different industrial applications. We made rotor spun yarns and ring spun yarns out of it. We have woven it into 100% SaxCell fabrics. And we, of course, tested the material on all properties. For example, we produced a fabric that has been traditionally produced by 100% cotton. We replaced the cotton for 100% with this chemical recycled SaxCell fiber. And what we've seen with the same weave structure, with the same yarn density and everything the same, just the raw material is different, is that on dry conditions, the SaxCell fabric is actually much stronger than the cotton fabric. So you actually make from cotton as a waste stream a new material which has better properties in that respect, in that regard, than cotton. It is known from regenerated cellulose fibers that they are reduced in strength when they are wet. So we also tested the wet strength. And as you know, cotton is usually getting stronger when wet. And what we have seen here is that even under wet conditions, their properties are very good, and it's at least comparable to existing cellulose fibers in the market. We produced different kind of garments with some Dutch designers to show the application. One nice property of their SaxCell fibers, but this is also known for other regenerated cellulose fibers, is that they can take up their dye stuff quite well. So what we did is actually we went to our partners, and we produced a towel with 50% of cotton and 50% of the SaxCell fibers in one towel. As you can see here, it's produced in as a white or uncolored fibers, and then it has been actually dope dyed. And what you can see here, we did several tests with this reactive dye stuff, is that the dye stuff gets easily into the SaxCell fibers, which are here the darker parts of the towels. Those are produced from the SaxCell fibers, and the lighter parts are actually cotton. So at the end, what we had is a towel where we have the logo of SaxCell in a darker blue than the surrounding cotton, which is here 50-50 blend by 100% cotton yarns here and 100% SaxCell yarns over there. And with that, in the piece dyeing of this towel, we can get those kind of nice effects. As I said before, we wanted to see if we develop something, of course, it should be more sustainable, because that's the whole issue of going into a circular economy and looking into these properties. So we did a life cycle assessment, and unfortunately, we couldn't do that for the fiber production as well, because those values were not available, but we looked into the pulp production, so getting rid of polyester and those kind of things. What we can say is, if we start with a feedstock of 100% cotton waste, we have lower impacts on all impact categories. I don't know if you're familiar with life cycle assessments, but it means that you're having lower environmental impacts and you have a sustainable process. Also, when we have cotton polyester blends, it's still lower or comparable. However, what I said in the beginning, if we have dark and intense colors, this removal of the dye stuff takes a lot of chemistry and energy. So that is actually producing higher impacts to the environment than just using raw cotton for your processes. So that should be avoided. So we went back to our processes, and we thought we need to develop something to overcome this. And we worked together with a workwear company, HAFAB in the Netherlands, and we produced a 100% chemical recycled workwear trousers for them. And we looked into the design for recycling. And we said, actually, look, most of the time you are working with blue overalls, which are of 100% cotton. Why not using that color back into our processes? And we have looked into the literature, and we have seen that also other universities have shown that the dye stuff can be kept inside of regenerated cellulose fibers by processing colored waste. You can see here those colored textiles on the left lower picture has been transformed into a chemical recycled fibers with keeping the dye stuff in the fiber. So we also looked into that and into the workwear of that company, and we actually have shown that using their blue workwear, as you can see on the right upper corner, we can transform that into a blue pulp without discoloration of the pulp, and that can be transformed into blue virgin SaxCell fibers. And of course, from that you can make a new pair of or new overall from those fibers as well. So we have shown that we can keep the dye stuff in the material. Of course, this has advantages and disadvantages. The advantage is it's a huge saving of environmental impact on two processes, because you don't have to discolor the waste, which saves a lot of chemistry and energy. And you also don't have to color your white virgin fibers. So you actually save a lot of environmental impact. However, you are depending on your waste stream. So depending on the waste stream we are using, we will get a different blue of your SaxCell fibers. And that, of course, is difficult to handle in the production if you would like to have constant colors of your products. Here you see an overview picture of that project. We did that with the different partners in our research group. Of course, we know that cotton is not the only material, and that cotton is used a lot in blends with polyester. And since we are working together with workwear companies, they ask us you have a process for cotton, but cotton is only a minor part of our collection. We are actually using most of our fabrics are polycotton blends. So we looked into that and we said we actually need a process where we can separate the cotton and the polyester in that material. And that is actually possible by chemical recycling processes. We have a new project funded for doing that. It's called Breakthrough in Polycotton Recycling. And together with these Dutch partners, we are actually developing a process how to separate polyester cotton blends and recycling polyester back into the loop and the cellulose from cotton back into the loop. This is all possible only with our partners that are involved in our research and, of course, with our lab facilities. We invested a lot the last years in our infrastructure. We opened last year a new laboratory, which is called the Circular Textile Lab. And you can actually visit it by using this link, which is on the top of this slide here. If you go to this link, you will see an introduction video of our Circular Textile Lab. That is a video that we produced for the opening of the lab. Now, almost 2 years later, it looks different because we added more equipment and we are very busy in this. What we can do in our lab here is now that we can work rapidly on prototyping for the textile industry. That means we have the two recycling processes that I've talked about, the mechanical recycling and the chemical recycling, and we can process them into recycled textile prototypes. For example, for a Dutch denim brand, Mud Jeans, we looked into their fabrics that they use, and what they usually do is they have spinners that can add up to 40% of mechanically recycled cotton into their products. That's their standard. That's also the maximum of recycled content, because as I described before, the recycled fibers are shorter than the mechanical recycling, and the yarns that are produced are weaker. So you cannot go with this technology higher than 40%. But we have the chemical recycling in our house as well. So we thought, can we produce a fabric which has 100% post-consumer recycled fibers, which means 100% fibers that have been used before in textile products and also washed and worn and then discarded actually. And what we did in our new laboratory, we made yarns and fabrics and at the end also a denim prototype with a mixture of mechanically and chemically recycled fibers, which allowed us to have 100% post-consumer material in denim. You could ask yourself, why not using 100% of the chemical recycled fibers for that, if they are stronger and if they are better fibers? That is because it has actually more reasons. One of them is that chemical recycled fibers, as I've show you before, has a higher environmental impact. So if possible, you should go to mechanical recycling. And the second factor is that these chemical recycled fibers, they are actually not cotton anymore, right? They are lyocell type fibers. And denim material from 100% lyocell would have a very different feel and touch as traditional denim. So actually, we wanted to find a good mix of strength, environmental impact, and also the feel and touch of denim. And that is what we did, and that is what we also achieved. So I talked a lot about our research, and important is that, as I've shown before, the whole value chain involvement. And we do that on a very local level in the Netherlands. We have different partners in our network that are closely located to us, but also closely collaborating with us in the waste collection, the recycling, and the production of new materials. And Saxion, as being the University of Applied Sciences, is the knowledge carrier in this consortium and is actually facilitating all parties in our network with the knowledge they need. And of course, we also have the chemical recycling technology in-house. This has been recognized as being one of the best practices in Europe. So we got this honor of being amongst 200 best practice projects in Europe recently. If you have the chance to visit us, please do so. We have quite a lot of laboratories which are not, and I think that's different to your faculty, on industrial scale. We have all equipments on a smaller scale, which actually allows us to do a very rapid research and prototyping. So we have a lot of equipment which we can use in a very fast way and doing changes and prototyping for that. We have a chemical and mechanical testing lab, a sample weaving loom, a circular knitting, and then the circular textile lab that I've shown before, embroidery, digital printing. And we use it for research, for innovations, not for production, of course. This is our network. I think most of it will not tell you a lot because it's more European based. IFTI is quite internationally based, but we are quite broadly connected in Europe at least. And of course, via our study programs as the Bachelor of Fashion and Textile Technologies, we are also spreading our knowledge and our students around the world. That's actually the end of my lecture and presentation. So I want to thank you again for having me for your lecture. It is an honor to present to you our research work, and I want to thank you for organizing it and all the organizers for inviting me. Thank you.
Okay, thank you, Dr. Ulrich, for your insightful lecture about the SaxCell and its potential applications. It's not only interesting, but also inspiring. At least we can recycle our clothes once we don't use it again. And then let's move to the next agenda. Agenda is the Q&A session. For the participants, if you have any questions, please write it in our chat box, or you might raise your hands and unmute your microphone to deliver your questions directly. Okay, there is one participant who raised a hand. For Miss Anissa Mukhtar, you can unmute your microphone and ask your question directly to Dr. Ularik.
Okay, thank you, Mas Satria ya. Ya siapa itu namanya tadi? Mas
Budiman.
Oh ya, Mas Budiman.
Yeah.
Thank you. First of all, my name is Anissa, and is it okay that I ask the question, but it's not about textiles, it's more general. It's more about sustainable textiles.
Yes,
Hello?
you're welcome.
Okay. Okay. So I understand that recycling is not easy in terms of production and everything, but is there any change that in the future recycled fibers or recycled product will be cheaper? Because I find it very expensive that the value behind it cannot reach all people. I mean, the awareness of sustainable textiles should be wider, should be reaching more people. And I believe it is not just about business. It should be more than that. It should be a new and greater lifestyle for the sake of the environment. But since it's very expensive, most people, especially the mid to the low ones, don't seem to understand the meaning behind sustainable textiles. So at the end, they will eventually still put their interest in fast fashion, and they still don't get what is sustainable textile and what is it for them. It's my question.
Yes, thank you for the question. It's really a nice and inspiring question, because it's also a different view than we have from Europe, maybe, because in my opinion, the problem is actually that the fast fashion is so cheap, because the mass production we have nowadays makes, of course, textile production very cheap and very attainable for lower prices, which means that people can buy more than they need. And that's actually a problem that I see, because of course, I can imagine that recycled materials are still more expensive than virgin materials. That has to do with the scale. Virgin materials are produced on a very large scale, and recycling is a new technology which is coming up. So I think in future, when we have a scale up of these recycling technologies, the fibers will be more affordable. But in general, we should ask ourselves if textiles should be that cheap as we at least see it in Europe. We have retailers that sell. It's difficult to compare to your situation, I think, but we have retailers that really almost give it for free to the people, the textiles, and so of course people are buying and buying, which I can understand, but for our planet it's not really sustainable, because it's taking away our resources, and we don't have those. And if the textiles are ending up on landfill, it's really messing up our environment. So I agree that it should be a lifestyle, and it should be a trend to buy sustainable textiles. And that's the key. I think designers need to make those choices and make recycled materials trendy, fashionable, and also achievable in price, of course, for everybody.
Okay, thank you, Mr. That explains a lot.
Thank you.
Okay, thank you. Miss Anissa, do you still have more questions?
I think no, that's
Okay.
all.
Yeah, thank you. You're welcome. Okay, for the participants, if you have any questions, you can write it in the chat box, or you can raise your hand, and then you can deliver your questions directly. By the way, we also send you a link for the participants to fill the form to get our e-certificate. I mean the attendance list, the link. For those who are lucky and gives good questions, we also tell you that you will have a chance to get some door prize or gift from our textile engineering department. Okay. I think there is a question from the classroom, right, Burina? Because sometimes the audio can have a problem. Okay, while waiting the question from our students, there is one participant who raised a hand to Mr. Alfian Galih Akbar.
Yes.
Yes, please you can ask your question there.
May I ask you, so as we know, textiles, especially those made of cotton, linen, etc., are renewable. It has less concern than oil and another non-renewables one. Maybe should a company explain its recycling ability to consumers to educate them? Thank you.
Yes, thank you for your question. And that actually has two aspects, I think, two very important aspects. One of it is that you said it's cotton is renewable, and that's of course true. It grows over and over again, but of course it has an impact on the environment, even if it is renewable. And the cotton grows, as we know, depending on the country and depending on the location, consumes water and pesticides and those kind of things, which might be problematic. But still, I'm supporting cotton in being a good fiber for textiles. On the other hand, if we make products out of it, and we would say we keep it in the biological cycle, so we make them compostable or decomposing in nature, that would be possible because they are compostable. But the chemistry we are adding with dye stuffs, with other treatments on the cotton, will also end up in our soil and in our ground and water. So that's a bit problematic. On the other hand, the question that you said, we really should inform, and the companies, the retailers should be transparent to their consumers what they are doing. Transparency is the key, but transparency, of course, is also difficult because you don't want to show your whole value chain, because then maybe others will take over the value chain if you show it to everybody. And of course, you have the risk that consumers ask questions to you. They ask maybe questions: why is your cotton coming from that country and not from that country? Why are you using those chemicals and not those? So you need to be aware of that. But I think transparency for at least European retailers is really a key.
Thank you.
Thank you.
Okay, Mr. Alfian, do you still have more questions, or is that already answered your question?
That's enough. Thank you.
Yeah, okay. Thank you.
Can I? Okay. Mr. Budiman, can you hear my voice? Check.
Yes, but it's still a bit echoing.
Oh, okay. Wait. Can you? Is this okay?
Yeah, that's fine.
Okay. So thank you so much. So here in the classroom, they have one student wanted to ask. So I would like to give the microphone into Hakiki. Please, you can stay.
Okay. First of all, thank you for your lecture. I have two questions. First, how to recycle the chemical waste to make SaxCell pulp And the second, the quality of textile and the first product before recycle, it is same or different? Thank you.
Thank you. Good questions to think about. If you are inventing a chemical recycling process, as we did, and you have to prove that you have a sustainable process, we did that with this life cycle assessment. That also includes your chemistry and chemicals that we use. And you know maybe the lyocell process that makes use of NMMO, which is N-methylmorpholine oxide chemistry, to dissolve the cellulose. And that can be recycled in closed loops as well in industry. All the other chemicals we are using are also recyclable or can be transformed to sustainable byproducts, which is all included in these life cycle assessment calculations. The second question was if the properties are the same and the quality or different. As I said, if we recycle cotton, but we actually produce a lyocell type fiber. And the lyocell, of course, has different properties as cotton. From their functional properties as strengths and those, lyocell are stronger than cotton. On other properties like abrasion, it's a bit less, but you have different properties. You can recycle the lyocell again back into SaxCell. So SaxCell you can recycle back into SaxCell, and you would get same kind of properties, but you have to add some cotton to it. So that has to do with the polymers in the molecules. They have to be refreshed with cotton waste at least. So you can recycle SaxCell, but you have to add in more cotton as well.
Okay, thank you for the explanation, Doctor. Okay, Bu Rina.
Yes, thank you so much for the answer. There is one more student wanted to ask. Okay, maybe Mr. Budiman, you can ask. Sorry, you can read the other question first. So because in here they have some something is not finished yet to write the question. Thank you so much.
Okay. Okay. There is one question from the chat box that I will read. The question from Ken Atik, UM Bandung. So, Doctor, the question is, where is the cotton fiber that is considered the best so far from? Is there any cultivation in Europe?
That's also a very good question, because there are these life cycle assessments, as we did it from SaxCell. You also have them from cotton. And there are also a few of life cycle assessments that show differences in the region where cotton has been cultivated. I don't know exactly by heart what regions are the best, but you should look into those literatures to see. We have not really cotton cultivation in Europe because the climate is different as what you would need. But I think, for instance, from parts of Africa, you can get good cost cotton, but also, of course, from parts of Asia. There are parts that need more water and more pesticide than others. Of course, you also have this distinction between organic cotton and conventional cotton. So if you're able to get cotton which has been cultivated without pesticides and without addition of other chemicals, you can go for those types of cotton. But please look into the life cycle assessments of cotton to get the answer there. There's one initiative which is maybe interesting to you in the Netherlands, since the Netherlands are also a country with a lot of agriculture, with a lot of expertise in that. There are actually initiatives to grow cotton in the Netherlands, but then in greenhouses. So in a surrounded environment, which is best for cotton cultivation. So that might be interesting. We cannot grow cotton on the fields in Europe.
Yeah, I think it's the same because in Indonesia we also don't have cotton farm. So we also get it from some countries in Asia and America, I guess. Okay, thank you, Dr. Ulrich. Okay, here we have Mr. Agus Taufik who raised hand. Mr. Agus, you still mute your microphone. Please, you can unmute it.
I'm so sorry.
Yeah.
Okay, thank you. Okay, thank you to Mr. Ulrich. Yeah, I'm so sorry because I couldn't reach this link from early. So I just only take the inform about there is a interesting statement about mechanically recycled fiber and chemically recycled fiber. So how do you think about that? I mean that which one of them that have friendly with the environment? Maybe you can explain me from the process, maybe. I think.
Of course. I will. Thank you. Thank you for the question. It's really important to distinguish there, because the mechanical recycling is actually for the environment the better process, because it's very it doesn't need any chemistry, it doesn't need any wet processes, which saves energy because you don't have to dry the fiber afterwards. It's just a mechanical tearing process which needs, of course, electricity or energy, but not more. So in view of sustainability, the mechanical recycling is better. The problem is that you are reducing the fiber size with that. So when you start with cotton, which once had between 20 and 25 millimeter, typically when you use post-consumer material like worn denim or something, when you recycle it, you end up with fibers on average of 13, 15, maybe if you do it well, 17 millimeters. So the problem is with those fibers, it's difficult to make good products. That's the difference to the chemical recycling. With the chemical recycling, we can make any product because we make actually virgin quality fibers. However, the impact on the environment is higher because you use chemistry. We use a wet process, which makes it necessary to dry the material afterwards. So it takes more energy.
Okay. Thank you, Mr. Ulrich.
You're welcome.
All right.
Mr. Budi, here there are one student wanted to ask again.
Okay.
Okay. Please, you can stay.
Good afternoon, Mr. Dr. Jens Ulrich. May I introduce myself? My name is Isa Amrullah. I'm one of student from Textile Engineering of Islamic University of Indonesia. I have two questions I want to ask to you. The first question is how to installation the spinning machine regarding to produce the SaxCell filament.
Okay.
And then the second question is, so the product after recycle is lyocell or another product such as rayon, modal, or viscose? Maybe that's it. Thank you. Good afternoon.
Thank you.
Thank you.
Good questions, relevant questions. So for the chemical recycling, you need to process the pulp into the fiber. And that is done with the traditional wet spinning for lyocell fibers. I think you know melt spinning and wet spinning. So a wet spinning processes the polymers, and that's here it's the cellulose is dissolved, and that's in this NMMO. And then you get a viscous liquid, which you are pressing through a spinneret, and then you make filaments. And these filaments are cut into staple fibers. So you need a wet spinning machine. This is how we produce the SaxCell fibers. And when you have cut the staple fibers from that, they are lyocell type, you can go on each yarn spinning equipment. You can make open end yarns, ring spinning, and we even tested it on air-jet spinning machines. So there is no limit anymore on spinning. On the other question was, I think I forgot about.
Okay, maybe Isaac can ask the second question.
Check. Okay, the second question is about. Okay, maybe I can help. So the second question is about the product of the what the name sexual pulp. This is like lyocell or modal or viscose or other. So thank you so much.
Yes. So we go from cotton to lyocell, and then if you recycle it again, you can make always lyocell out of it. So in our SaxCell process, we produce the lyocell fiber.
Okay, so it's similar to lyocell fiber, right?
Yes.
Okay. Thank you, Dr. Ulrich, for your answer. Ladies and gentlemen, I guess the time is almost over, so we will go through to the last question. Here in the chat box, we have one question from our students. She joined online. Ajeng, would you like to deliver your question directly, or? Hello, Ajeng? Okay, maybe there is a problem with her audio, so I will read her question to you. So she is curious about what are the common sustainability issues in textiles in Europe nowadays.
Yes, thank you. Yeah, I think it's a bit different in the situation as in your country, because in Europe we almost don't have any textile production anymore. So the local issues with textiles are not related to production. They are more related to the waste, because we have strong retailers. They are getting textiles from Asia and other countries into our country and our continent, which is okay, but we have the problem that we are stuck with the waste. And recycling gives us in Europe a way to get our own raw materials. As I said, we are not producing cotton in Europe, and we also are not producing on large scale other types of fibers for textile industry. So we actually have no raw materials for textile industry. We have to import them, but we have a lot of waste. So if we are is it possible to process our waste into fibers and to a raw material, we can start up an industry again in Europe.
Okay, thank you very much. Now the time is 3:30 p.m. Before the closing, we would like to thank and appreciate Dr. Jens Ulrich, who has given us his lecture, and we thank also all the participants who are attending this event until the end. Please give us virtual applause that you might click on the bottom of our Zoom screen.
Thank you.
Okay. And also for your information, the e-certificate will be sent to your email in 3 working days. In addition, new student registration to our Textile Engineering Department for Bachelor Degree Program is also still open. Please visit the website pmb.uii.ac.id. Well, ladies and gentlemen, I think that is all. Let us close our event today by reciting Hamdalah. Alhamdulillah.
Alhamdulillahirrahmanirrahim.
Once again, thank you to Dr. Ulrich for being with us today. Thank you, everyone. Enjoy your day, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Bye-bye.
Thank you, Jens Ulrich.
Bye.
Nice to meet you.
Okay, Burina, maybe the students will take the photo.
Oh yeah, I'm so sorry,
yeah.
Dr. Orange.
photo.
So we wanted to take picture with you. So just
Okay.
please keep in there. We wanted to take from the classroom. Okay.
That's fine.
Thank you so much.
Yeah.
Okay.
Yeah, we have a big screen in the classroom, so the screen display your image, so then the students will stand around and then we'll take the picture.
Okay, no problem.
Yeah. So in the participants, there is the name students room GL. So that is the classroom that the students join the lecture today.
Yeah, I've seen them. It was very well organized. Thank you for that.
Thank you.
When will you come to Jogja?
That's a good question. I have been closed once. I have been on Bali once, but actually I'm not planning to fly a lot. Also concerning sustainability, I'm quite happy that we can do it online. But of course, it's different to meet people physically.
I see.
Maybe we could join once on a conference or something. I don't know, maybe there's some opportunities.
Yes.
Okay, Burina, maybe you can give a sign when the picture will be
Thank you
taken.
so much.
Yeah?
I think it's finished. Thank you so much.
Okay.
You
Sorry,
didn't get my best smile.
Yeah.
But that's fine.
Udah. Okay, thank you so much for Dr. Orange. So
Thank
okay,
you all.
Mr. Budi, you can close it. Thank you.
Yeah, okay, you're welcome. Okay, Dr. Ulrich, you may leave the Zoom room if you have any agenda.
Okay, yes. Thank you all. Have a nice day.
Okay. See you,
Bye-bye.
Ulrich. Bye. Mbak Rina ke lab nggak?